Next is question number 71, which says that if fx is equal to modulus of x square minus 4x plus 3, then which of the following is incorrect? Now in the options it have been asked about f dash x, right? So firstly, making the factors of quadratic, we can write fx as modulus of x minus 1 into x minus 3, right? So removing the modulus, we can write fx as x square minus 4x plus 3 when this term is greater than equal to 0. That is, when x belongs from minus infinity to 1 union 3 to infinity, right? And it will be minus of x square minus 4x plus 3 when x belongs from 1 to 3. That is clear? Okay. Now, to find the value of f dash x, it will be equal to 2x minus 4 when x belongs from minus infinity to 1 union 3 to infinity, and this will be minus of 2x plus 4 when x belongs from 1 to 3. So now we will check all the 4 options, right? Now, firstly, let us find the value of f dash minus 1. For minus 1 is falling in the first range, that is this one. So this will be equal to 2 into minus 1 minus 4. That is equal to minus 6. So this one is correct. Similarly, we will find the value of f dash 0, which is also falling in the same category. So this is equal to 2 into 0 minus 4, that is minus 4. But here it is given minus 2, so this is incorrect, right? Similarly, the other 2 options can also be checked. Let's move on to the next question, that is question number 72, which says that if z1, z2, z3 are the complex numbers such that mod z1 is equal to 1, mod z2 is equal to 2, mod z3 is equal to 3, then the maximum value of mod z1 minus z2 whole square plus mod z2 minus z3 whole square plus mod z3 minus z1 whole square is. Now, we know that z1 plus z2 plus z3 mod whole square is always greater than equal to 0, right? Now, we know that mod z whole square can be written as z into z bar. So, it can be rewritten as z1 plus z2 plus z3 into z1 bar plus z2 bar plus z3 bar is greater than equal to 0, right? So this can be written as z1 into z1 bar, writing it again as z1 mod square plus z2 mod square plus z3 mod square plus z1 z2 bar plus z1 z3 bar plus z2 z1 bar plus z2 z3 bar plus z3 z1 bar plus z3 into z2 bar is greater than equal to 0, right? So this is what we get from here. Now it can be rewritten as mod z1 square plus mod z2 square plus mod z3 square is greater than equal to minus of z1 z2 bar plus z1 z3 bar plus z2, this is 1, z1 bar plus z2 z3 bar plus z3 z1 bar plus z3 z2 bar, right? So this is the inequality which we get from here. Now we have to find the maximum value of this one, so let us expand it. Can be written equal to mod of z1 minus z2 whole square, that is mod of z1 square plus mod of z2 square minus 2 times z1 into z2, right? So similarly, expanding the 3, we will get 2 times mod z1 square plus mod z2 square plus mod z3 square, right? 2 times of this minus z1 z2 bar plus z2 z1 bar plus z2 z3 bar plus z2 bar z3 plus z3 z1 bar plus z1 z3 bar, right? Now we know that minus of this value is less than equal to mod z1 square plus mod z2 square plus mod z3 square. So this can be written less than equal to 3 times mod z1 square plus mod z2 square plus mod z3 square. Now we know the value of these three, so these can be substituted. So we will get 1 plus 4 plus 9, right? So this is less than equal to 14 into 3, that is 42, right? So the correct answer is option number 3. Next is question number 73, which says that if I is equal to limit x tending to 0, GIF of x raised to the power fractional part of x plus modulus of x minus 1 to the power signum x, right? We have to find the value of I here. Okay, so this can be written equal to, let us firstly find the right hand limit, that is limit x tending to 0 plus, right? Let us say that is I1. So this can be written as when x is tending to 0 plus, so the value of greatest integer of x will be 0, right? And the value of signum of x will be equal to 1, right? So here writing 0 raised to the power x minus 0, that is again 0, plus mod of x minus 1 raised to the power 1, right? So here directly x can be put as 0, so that will be equal to modulus of minus 1, that is 1 raised to the power 1, right? So this is equal to 1. Similarly, let us find I2, that is limit of x tending to 0 minus. So this will be equal to, when x is tending to 0 minus, the value of greatest integer of x will be minus 1 and the value of signum of x will also be minus 1. Okay, so this can be written as minus 1 raised to the power fractional part of x can be written as x minus greatest integer of x, that is minus 1. So this can be written as plus 1 plus modulus of x minus 1 raised to the power minus 1. Here x can directly be put as 0. So that is 1 raised to the power minus 1, that is 1. Here also putting x equal to 0, we will get minus 1 raised to the power 1, that is minus 1, plus 1 equal to 0. So we can say that the limit of the given function does not exist. So the correct answer will be option number 4. Next is question number 74. It says that if modulus of z2 plus iota z1 is equal to mod z1 plus mod z2 and mod z1 is equal to 3 and mod z2 is equal to 4, then the area of the triangle ABC with affixes of vertices ABC are z1, z2 and z2 minus iota z1 upon 1 minus iota respectively, where iota is equal to root minus 1 is. Now, as here it is given this equation. Now, this equation is only possible when argument of z2 is equal to argument of iota z1, right? Only then this equation can be satisfied. So, solving this further, we can write it as argument of iota plus argument of z1, right? That is, we can rewrite it as argument of z2 minus argument of z1 is equal to argument of iota, that is pi by 2, right? So this is first equation that we get from here, right? Now, let us assume this third vertex C as z3, right? That is, z3 is equal to z2 minus iota z1 upon 1 minus iota, right? So solving this further, we can rewrite it as z3 minus iota into z3 minus z2 plus iota z1 is equal to 0, right? So this can be written as, taking iota common, z1 minus z3 is equal to z2 minus z3, right? That is z2 minus z3 upon z1 minus z3 is equal to iota. This is the second equation that we get. Now, from equation 1 and 2, we can draw Z1, Z2 and Z3 on coordinate axis. Let us say this is X and this is Y. So here it is given that argument of Z2 minus argument of Z1 is pi by 2. So it is something like this, where this is Z2 and this is Z1, right? So the angle between them is pi by 2. Similarly, it is given that Z2 minus Z3 upon Z1 minus Z3 is again iota, right? So the angle between these two is again 90 degrees, right? So joining these 2 points, let us say these points are O, A, B and this is C, right? This is Z3, right? So here it is given that mod Z1 is 3 and mod Z2 is 4, right? So from here we can find the value of AB, which will be equal to, by Pythagoras theorem, under root of 3 square plus 4 square, that is 5. Now from here we can see that if I take modulus on both sides, so we can say that modulus of Z2 minus Z3 is equal to modulus of iota is 1. So this is equal to modulus of Z1 minus Z3, right? So from the given diagram we can say that Z2 minus Z3, that is BC, is equal to Z1 minus Z3 mod, that is equal to AC, right? So these two sides are equal. So in the triangle ABC, we can see that in triangle ABC, we can say that AB square is equal to BC square plus AC square. But as AC is equal to BC, so we can say that this is equal to 2 times BC square. Now AB square is equal to 25 from this equation. So this is equal to 25. So from here we find that BC square is equal to 25 by 2. Now we have to find the area of triangle ABC. So area of triangle ABC can be written as it is a right angle triangle, half into base into altitude, and base is equal to altitude. So we can write it as half into BC whole square, which is equal to 25 by 4 square units, right? So the correct answer is option number 3. Next is question number 75. Which of the following is a tautology? 4 options are given and we have to check all of the options one by one. Now let us firstly make truth table. Let us say this is P and this is Q. Let us take the values as TT, TF, F, T, F, F, right? Now the first option says P to Q. This is clearly when it is TF, then it is F, otherwise it is T. So this is not a tautology, so this is not the answer. Similarly, you can see for Q to P also, only this is F, rest all are true, right? So this is also not a tautology. Similarly, going for third option, it says that this will be T, F, F, T, right? So this is again not the answer. So let us now check fourth option, which says that P to Q or Q to P. That is, we have or between these and these. So this will be T, 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 right? So this is a tautology. So the correct answer will be option number 4.